Alright, so this video is about adding and subtracting polynomials. And the first example says subtract 4x, subtract 3, then subtract, in parentheses, 7x, subtract 5. And if you want to subtract those, we got to first decide what's in front of the parentheses. For example, in this first set of parentheses, there is no number in front, so there's an understood 1 in front of that parentheses. So you take 1 and you multiply it to anything, it doesn't change anything about it. So that becomes 4x subtract 3, because 4x subtract 3 times 1 is still 4x subtract 3. All right, and the other part says subtract 7x subtract 5, because that has subtract as parentheses is understood 1 here. That understood 1 changes everything in the parentheses sign. So to say 7x subtract 1 times this negative 1, basically makes it the 7x become negative and makes a 5 that says subtract 5 become positive. And again, the reason why is there's a subtraction sign in front, and you multiply by anything by negative, it changes its sign. So I'm cleaning up a little bit, read these little straight marks. And from there, we want to combine our like terms. So we have like terms that are here and here. So when we say like terms, we include the term and the sign in front of the term. So 4x and negative 7x are like terms. And then negative 3, I'm going to use a little v underneath it, and positive 5 are like terms. So when we combine those, 4x take away 7x's. So if you have 4x's and you take away 7x's, you're left with negative 3x's. Your 3x's in the negative direction. And then negative 3 plus 5 is positive 2. So that's what you would actually simplify that to be. All right, so anyway, I will pause the video and copy that as a note. I'll give you another example just like it. Now, after you pause it and copy it down, I'm going to erase all this. Somebody erase it now. All right, I got a new example. This one says add. You're going to add parentheses 2x squared, subtract 5x, plus 8, then plus parentheses 5x squared, subtract 7x, subtract 12. So you're going to add those. So if you're going to add those, all right, so if you're going to add those, basically you got to decide the sign that's in front of the parentheses, and because there's, or better yet, the number and the sign is in front. And because there's nothing in front of this set of parentheses, it's an understood positive 1. So it means 1 times it. There's nothing there been multiplied to it. It's understood 1 there. So positive 1 times those, we just decided it doesn't change the sign. So all these come down exactly as they are, because there's a positive 1 being multiplied to it. Here is a positive 1 being multiplied here as well. So when you multiply that by positive 1, you wind up having 5x squared, subtract 7x, subtract 12. So both of those basically come out of parentheses. So when you add the like term, you're basically adding the like terms just as they are. So the 2x squared and the 5x squared are like terms. And then the negative 5x with a circle around it, and the negative 7x are like terms. And then the 8 and the negative 12 are like terms. So when I combine my like terms, 2x squared, and then take away 7x, better yet, 2x squared goes with 5x squared. So 2x squared plus 5x squared gives you 7x squared. 2x squared plus 5x squared is 7x squared. Negative 5x and negative 7x basically have the same sign in front, negative. So they really get to be negative 12, because they really like add with the negative sign. And the last one is positive 8 and negative 12 here. So positive 8, take away 12, so that would leave you with 4, negative 4. So when you combine those, your final answer is here. And that's how you add those two. Pause the video, I got another one for you. And pause the video and copy the note down. Then we'll give you a new one. I'm about to erase this stuff. Okay, so the new one. I have 3x squared, subtract 5x, subtract 8, then subtract all of this in parentheses here, right? So since that subtraction there, basically these don't change. The first set does not change. It's still going to be 3x squared, subtract 5x, plus 8. But that subtraction here, means there's a negative 1, then multiply to all of those, and all of their signs have to change. So the positive 8x squared becomes a negative 8x squared. And then the negative 7x becomes it, because of that negative 1 times it, is going to become a positive 7x. And the negative 11 becomes a plus 11. So you're looking for like terms. So after you get there, looking for like terms throughout this problem, we have an x squared term here. I'll put a box around it. So it's 3x squared and negative 8x squared. You can put any symbol you want around it. And then I see the negative 5x. So we use a little squiggly bar. And there's a x right here, so it's a 7x. So those are like terms. And then the last one is the 8. So the 8 pairs up with the 11. All right, so when we look at this and combine our like terms, 3x squareds take away 8x squareds, but that leaves you with negative 5x squareds. And then negative 5x's plus 7x's, because the 7 is a bigger number, has a bigger absolute value, it takes the sign of the 7. So negative 5x plus 7x is a positive sign, because 7 is positive. And you got 2 x's as a difference. And then 8 plus 11. 8 plus 11 is clearly 19. And the final answer is this. So that's how we can add those polynomials. That's pretty much all there is to know about adding polynomials. The only thing I could really make it different is I can add words to it. So I'll give you an example of that. Pause the video and copy this as a note, and I got a new one for you. All right, so this last example, only thing I can add difference to it is adding words. So this says add x cubed, subtract 3x squared, plus 5x, subtract 7, and add that to x to the 4th, subtract 4x to the 3rd, subtract x, plus 9. So we're going to add those. Lots of ways you can add them. You can add them horizontally or vertically. So I'm just going to add them horizontally. So I'm going to write it all in one list. So I'm going to write x to the 3rd, subtract 3x squared, plus 5x, subtract 7, plus x to the 4th, subtract 4x to the 3rd, subtract x, plus 9. And what we're looking for are the like terms. So going through this, x to the 3rd, I have an x to the 3rd here, and I have an x to the 3rd there with the negative 4 in front. So I'm going to put a box around it so I can remember to keep the negative sign before. I'll put a box around the first x to the 3rd. Then looking down again, I see an x squared here, but I don't have any other x squareds anywhere in my list. So because of that, the x squared doesn't have any like terms. So it doesn't add to anything. It's going to stay exactly as it is. And I look at 5x here, and then I have another x here with the negative sign. So those two are like terms. And then the negative 7, put a big circle, and the positive 9 are both constants, so they're like terms. So all my like terms are going to add first. So I have x to the 4th. If you notice, x to the 4th has no like terms either. So I'm going to add my like terms first. I have x to the 3rd, take away 4x to the 3rds. Those add to be negative 3x to the 3rd. And then 5x and negative x. That's like 5x's take away 1x. So that gives you a positive 4x's. So you had 5x's and you took away one of them. The next like terms are negative 7 and positive 9. So negative 7, you add 9 to it, you get 2. And I've added all my like terms. The only thing left are the unlike terms. So I have negative 3x squared left, and I have a positive x to the fourth left. So they're just left there on the end. Truthfully though, we like to leave our answer where the exponents go downwards in order. And what I mean is x to the fourth should come first. So I'm going to rewrite that. I'm going to rewrite it as this. It should be written as x to the fourth. And the next exponent down is x to the third, so it becomes negative 3x to the third. After x to the third, the next exponent is x squared, so it's negative 3x squared because of this one here. After the x squared becomes 4x, because x to the first is the next exponent down. And after x, there's no x's left, so the last number is the plus 2. So our final answer is here. All right, so that's it. I'll pause the video and I'll copy that as a note because I'm about to erase the screen. Well, actually, there's everything. That's a lesson for adding and subtracting polynomials. So with that being said, make sure you have that down as a note. I'm gonna give you about three or four more examples of practice before you come to class tomorrow. In 1 second. All right, so on your own, try just these two. So write these down and try these two and bring them to class with you tomorrow. That's all I have. Good luck.